Hi there, it's Dr. Carrie Ann. Citizen science has always been a great way to participate in science, but now it also offers a powerful gateway to learning. Today, I'm going to introduce you to one of my favorite projects available on SciStarter.org, Sourdough Science, and I'm going to give you some tips on how to extend the learning beyond the science of the project. Humans have been making, baking, and eating bread for over 10,000 years. But scientists still don't know a lot about those microbes that give us all those delicious carbs. Participating in this project will help scientists to better understand how the types of flour influence microbial growth, and those microbes in turn determine the texture, flavor, and aroma of the bread that we love to eat. This project is a great jumping off point for a bunch of important topics in biology and chemistry. You can extend your learning into microbes, pH, anaerobic and aerobic respiration, fermentation, data collection, and graphing, just to name a few. So let's go over the basics of what doing this project looks like, and then I'll come back and give you some ideas for how to go even further. The Sourdough Science Citizen Science Project is great for the classroom or home because it doesn't require a lot of specialized supplies, and you can ramp it up or ramp it down depending on the age and ability of the students you're working with. You probably will need to special order some pH papers from a place like Amazon. Other than that, you should be able to round up everything else in your house or classroom. Go to the website and you can download detailed directions and a materials list and print off a copy of the data sheet that you'll need to record all of your observations. Once you have everything in place, you're going to set up your experiment, something like this. Notice that each jar has a label. Those labels include the start date, the type of flour in the jar, and my initials, so we know who did what when. And every day, we're going to take some important measurements. One, we're going to measure our pH each day with a new, fresh pH strip. You're going to touch it to the back of your sample so it doesn't discolor your pH squares. That'll just make it easier to read when you go to compare it against the color chart. You're also going to measure the height of your starter each day, and both of those measurements will be recorded on your data sheet. And lastly, you also want to do an aroma test most days, which means you're going to need to uncap it just like you would to do the pH or the height measurement, and then you're going to take a big whiff, and this one smells really sour. It's well on its way to forming a great sourdough starter. Then you can cover it back up and put it back in a spot without direct sunlight. After 14 days, you'll have completed your data sheet and have a sourdough starter. Let's talk about ways to extend our learning from this project. An obvious question to ask is, what are those microbes doing in there that's turning it into sourdough starter? Which in turn might lead students to wonder, how do microbes make yogurt? Well, now you can get into all sorts of research and investigation into cellular respiration, both aerobic and anaerobic and even fermentation. Or maybe students are interested in pH. What is pH? What do we mean by an acid, and what makes something an acid? Or what makes something basic, and what do we mean by that? You could also have students investigate the macromolecules that make up living things. So bread is a carbohydrate predominantly. What are the other macromolecules that make up living things? And why do they make up living things? And do they share anything in common? Why do we call them macromolecules? Those are just a few ways that you can go further with this project and touch on topics that are going to show up in traditional chemistry and biology classes. After all, the more you know, the more you know.